Good evening, Fatima. Am I audible? Okay, just wait a second. Okay. So in the last lecture, we did preparation of alcohols. Correct? We did first of all from alkenes. From alkenes. And from alkenes, we had first of all, we did with hydroboration of alkenes, and we also did acid catalyzed hydrolysis. Acid catalyzed hydrolysis. So in acid catalyzed hydrolysis, what happened? We had an alkene and we treated this with water in the presence of acid, and we got a alcohol that had the OH group in the more substituted position. That means with the less number of hydrogen atom, more substituted and less number of hydrogen atom. Secondly, we did with hydroboration, oxidation. Hydroboration, oxidation. Okay, in hydroboration, oxidation, what happens? We treat alkenes with BS3 twice, that is diborane. It exists in the form of diborane, but BS3 is the one that takes part. And secondly, so what forms first? What forms first is we have trialkyl borane. We have boron, and it has, okay, I have to make 3 carbons because we have 3 carbons here. 1, 2, 3, and boron. And 1, 2, 3 borons. Yes. So this is trialkyl borane. This is trialkyl borane. And when we treated this with H2O2 in the presence of NaOH, sodium hydroxide, what did we get? We get terminal alcohols. That is, we got 3 of terminal alcohols, CS3, CH2, OH, and we got BOH whole thrice. Okay, BOH whole thrice. So in the first sequence, what do we have? We have alcohol in the less number of hydrogen atom, in the carbon which has less number of hydrogen atom. This is Markovnikov's addition. Markovnikov's addition. And this, by hydroboration oxidation, we get anti-Markovnikov product, that is anti-Markovnikov addition. Anti-Markovnikov addition. Okay. And also remember, in this acid catalyzed hydrolysis, this goes via carbocation, Okay, just keep that in mind. In case you have to do some kind of free methyl shift or hydride shift, then you have to have this information via carbocation and Markovnikov addition. This is anti-Markovnikov addition. Okay. Now, we didn't do any other, as far as I can remember, we didn't do any other preparation now. Or we did we do some other preparation also? No, no? Okay, fine. So second is from carbonyl compounds. Carbonyl compounds. From carbonyl compounds. Okay. So first of all, carbonyl compounds. What are carbonyl compounds? We have any compound with C double bond O, and this is called carbonyl compounds. And what are the 2 carbonyl compounds that we have? The 2 carbonyl compounds that we have are aldehyde and ketones. That are aldehyde and ketones. Aldehyde and ketones. So number 1 is from reduction of aldehydes and ketones. Okay, aldehydes and ketones. So if I take an aldehyde like this, R, which is bonded to a carbon atom, double bonded to oxygen and a hydrogen, okay, and a hydrogen, and we add a reducing agent such as we can use H2PD, H2 in the presence of PD. So what will happen? One hydrogen will get attached to oxygen, one hydrogen will get attached to the carbon, and this particular pi bond will break. So what we will be getting? R, C, OH, and H2. Okay. Since first here there was one H, now we did a reduction. So this will be H, and also we will be getting an H here. Okay. The second, what else can I use? If I have R, C double bond O, and H, and I use either LiAlH4, that is lithium aluminium hydride, or I use, let me write it, or I use NaBH4, that is sodium borohydride, then also I will get the same product, that is R, one hydrogen at the oxygen and one hydrogen at the carbon. Similar is the case. Now this is 1 degree alcohol. You can see that this is also 1 degree alcohol. And this was what? These are aldehydes. Both of them are aldehydes. Aldehyde, correct? Now if I take a ketone, and whether I go from R, C, double bond O, and I am taking this as R dash, that means that these two R can be same or different. No matter if I go from the H2PD, H2 in the presence of PD, or I go, okay, wait a second, let me erase this. Whether I go from H2PD or I go from the root of LiAlH4, or I go from the root of sodium borohydride, NaBH4. All three of them will give me the same product. That is, one of the hydrogen will get attached to oxygen and the other will get attached to carbon. So I will be getting RC, R dash. This is OH now, and this will be what? Hydrogen. This will be hydrogen. I remember one point, that when you have aldehydes, you get 1 degree. When you have ketone, you will be getting 2 degree alcohols. 2 degree alcohol. Okay. Now, as of now, you have to remember these reducing agents. Okay. In a box, I mean, you can remember these reducing agents. So what are these reducing agents? Wait a second. Till now that you have learned, there are 3 reducing agents you have learned. Reducing agents. Those which are responsible for reduction. Reducing agent, number 1, H2 in the presence of PD, the presence of palladium. Secondly, you have learned LiAlH4. And the third, which you have learned, is NaBH4. Okay. Now, these are the 3 reducing agents that you have learned. Okay. You can copy this and we can move on. Also, the mechanism of all these are not in your syllabus, and these are pretty complicated mechanism. Simple mechanism that you have are in your syllabus. For example, if you have nucleophilic substitution, elimination, those are in your syllabus. Electrophilic substitution also, for that matter. Copy this and let me know when you're done. Okay, done. Okay. Now the next class of carbonyl compounds that we have, are called carboxylic acid and its derivatives. Okay, these are carboxylic acid, carboxylic acid, and its derivatives. So in the first case, both are same. What do you mean by both? Which I didn't understand your case. I didn't understand your question, by the way. From reduction of aldehyde and ketone, these two are different. Now, this is aldehyde and this is CHO group. Ketone is CO group. Then, okay, then frame your question in a bit. In the first case, what are the both? What do you mean by both? Yeah, the reduction of no sir with reducing agents. Still I didn't get it. What do you mean by both? Two different reducing agents? Yes. Fine. Yeah, these are two different reducing agents, but the result is the same. Okay, and here you have, I mean, three reducing agents exactly. Okay, this is LiLH4 or sodium borohydrate. Okay, so you have three reducing agents, and the product is the same. That is alcohol. Okay. I mean, we are preparing alcohol, so the result will be the same only. The only difference is you get 1 degree alcohol here if you have aldehydes, and you get 2 degree alcohols if you have ketone. Okay, if you have ketone. Okay, and moving on to carboxylic acid and its derivatives. So carboxylic acid, the same thing is there. You have RCOOH, okay, RCOOH, and if you treat this with LiLH4, okay. Now you have to remember, a carboxylic acid does not do any reaction with sodium borohydrate. It will need lithium aluminum hydride. Okay, and the second step, you have to add some water. And you will get RCH2OH. 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 Okay. Now, this RCOH, and the next reaction is for esters. If I take, for example, esters, RCOO, R dash, this is an ester. Now, if I react this with also H2PD, H2 in the presence of PD, that is catalyst, it gives the reaction RCH2, RCH2OH. Now this is RCH2OH, and this RO, this gains the another hydrogen, and it will become ROH. So RCO, RCH2OH, and ROH, two different alcohol. Okay. Now wait for a second. You have to remember just this table. If you have any C double bond O, and there is a reducing agent, okay, you will get RCH2OH. Now this CO will become OH. When now you have different kinds of reagents, and you have different kinds of substrate also. There are different reagents and there are different substrate. Okay, so number of reagents that we have just learned are 3, so we will focus on that only. Now let me just arrange this in a good way. Now, first of all, we had, let us take aldehyde and ketones. Then we can take aldehyde, ketone. This will be for acid. This will be for esters, and the last one will be for acid chloride. One more, a new different information. Okay, so now if you have LiAlH4, then what happens? If you have sodium borohydride, then what happens? NaBH4. Okay, and if you have H2PD, then what happens? Okay, if you have H2PD, then what happens? So you have got three different reagents, and you have got three different reagents, and the number of products. I mean, what are the substrate that we can have? We can have either CHO, this is aldehyde. We can have either C, this is R, C double bond O, and again R. This will be ketone. You can have either COOH. This will be what? This will be acid. You can have either COOR, and you can have either COCl. This is called acid chloride. Acid chloride. Okay, it's called acid chloride. Now, what are the reaction that they give? What are the reaction that they give? So, in presence of LiLH4, this ketone will give this reaction. Sorry, aldehyde will give, ketone will give. Acid, yes, acid will also give in the presence of LiLH4. COR, will this give in the presence of LiLH4? Yes, it will give. And in the presence of RCOCl, yes, it will give. What about sodium borohydride? It will only give in the presence of aldehyde and ketones, not in the presence of acid, not in the presence of esters, but it will give in the presence of acid chloride. What about H2PD? It will give in the presence of CHO. It will also give in the presence of ketones. It will also give in the presence of ketones. Now, for esters, you can have H2PD. For esters, you can have H2PD. There remains two more. That is in the presence of acid and acid chlorides. So H2PD, it does not good result. Not good result. Okay, I mean, it is not a very good reaction, not effective reaction. And for RCOCl, it is also not effective. So you can remember for NaBH4, LiLH4, these tables. But if you have RCOH, you better not use H2PD. And for COCl also, you don't use H2PD. Rather, you can use LiLH4, lithium aluminum hydride. So if you want to reduce a carbonyl compound, lithium aluminum hydride is your go-to compound if you want to convert any carbonyl compound to alcohol. If you want to convert any carbonyl compound to alcohol, you can have lithium aluminum hydride. You just note down this table. Oh, wait a second. First this. Okay. Then this one. Done. Okay, fine, great. Now, do this question. Form the major product. Form the major product. So you have what is this? Is this a benzene? No, correct. So this is a cyclohexane, and we have a ketonic group here, and this is CO, C double bond O, and this is OCH3. This is OCH3, and you have treated this with the presence of NaBH4, the presence of sodium borohydride, that is NaBH4. Okay, do this, and second one is a simple compound. So I can see two carbonyl compounds here. This is a reducing agent. This is number 1. This is 2. Okay. And here only I can see one carbonyl compound. If you can see that, this will be C double bond O, and this will be H. So I have here only one carbonyl compounds. So the second one will be easier. Tell me about the first one. Which is the, can both of them get reduced, or only one of them will get reduced, or what will happen? I'm giving you some products. This is the major product, or this is product A. Product B will be something like this. And product C will be something like this. Tell me A, B, or C. Okay, you're telling me A. And for the second one, did you do the second one? Okay, the second one is pretty easy, I guess. Second one is pretty easy. Wait a second. How many carbons are there? 1, 2, 3, 4 carbons. So you will be getting something like this, CH2 OH, correct? One carbon, 2 carbon, 3 carbon, 4 carbon, 1 carbon, 1. Yes. You got this product? I'm waiting for no. Yes. Okay, fine. Now let us go to the first question. First question you have. Now you tell me what is the one? What is the functional group at position at this one carbon that I have denoted in? Let me denote this in red, and let me denote one in green. Okay, this carbon. It's 2 here I've written. This is in green. Okay. So now you will tell me this red one is what? What functional group is this red one? Ketone, correct. And what is the green one? Is it also ketone? Oh, no, it is not ketone. Na? See, can you see? This is CO, OCH3. Can you see this whole group? This whole thing? This is COO. Yes, so it is ester, na? This is ester. See, COOR. Got it? And NaBH4 does not reduces esters. So A will not be a product because it is reducing esters, and also B will not be a product because it is reducing esters. The C will be the product because here only the ketone is reduced by NaBH4 and the ester group is intact. Got it? Okay. Now let us try one more question. Now give me the product for, okay. Sodium borohydrate. Okay, I am numbering these carbons. One, this is C double bond O. Okay, first tell me how many carbonyl groups can you see? How many carbonyl groups? Groups, very good. Three. So I'm guessing you are identified 1, 2, and 3. Okay, and which of them will get reduced? Which of them will get reduced in 1, 2, and 3? I mean, which of them will be converted into alcohol? Which of them will be converted into alcohol? Yeah, very right. 1 and 2. Okay. Now let us do one more example. Okay, fine. I'm writing the product. Write the product. You also write the product. You have this as intact COOH, and here you have a second degree alcohol. And here you have CH2OH. Okay. Let me know if you are done noting this. So as soon as you see something reducing agent like sodium borohydride or lithium aluminum hydride, you first identify the carbonyl carbons, how many carbonyl carbons are there. Then you go back to that table and then you reduce that particular carbonyl carbons, which can be reduced by the given reducing agent. Okay, now moving on, we have third here, the third case. First of all, from alkenes, second is from carbonyl carbons. Alkenes, in alkenes, we have two cases in which we have hydrolysis in the presence of acid and hydroboration of alkenes. In hydrolysis of alkenes, in the presence of acid, we get Markovnikov product, that means 2 degree or 3 degree alcohol. In hydroboration alcohol, we get primary. And in H2PB and reducing agent, and by reduction of carbonyl, we get, for aldehydes, we get 1 degree. For ketones, we get 2 degree. For carbonyl carbons, for carboxylic acids, we get 1 degree. And for esters also, we get 1 degree. Now moving on to from Grignard reagent, and this is one of the most important part in preparation from Grignard reagent. Grignard reagent. You remember Grignard reagent? We met it in the previous chapter. We met this in the previous chapter, right? Yes, right, from RMGX. Okay. So Grignard reagent, that is RMGX. RMGX gives alcohol on treatment with aldehydes and ketones. Aldehyde and ketones. Aldehyde and ketones. So how does the reaction go? So if I want to write a generalized reaction, I can write C double bond O. Now, if you have something like RMGX here, then what you will get here is carbon. Now this R, it will attach to this carbon, and you will have OH here, and you will have OH here. Now, this is a general reaction. And how does the mechanism go? The mechanism is like this. First of all, we have C double bond O. Now I want you to identify the electrophilic and the nucleophilic sites. Okay, we have R, Mg, X. Now you tell me, in this carbonyl carbon, we have C and double bonded O, C and double bonded O. So what do you think? C double bonded O, which carbon will have a delta positive or negative? Just tell me, delta positive or negative? Delta positive. Okay, delta positive. Now tell me about tell me about this RMGX. In RMGX, I hope you remember, R will contain delta positive or delta negative. Delta negative, because it is connected to a metal, and this metal will be electropositive. It will be giving them electrons, and R will be delta negative. So this reaction can happen that R can go and attack to the carbonyl carbon, and you will get a adduct here. You will get an adduct here. As soon as this R attacks carbon, that means it wants to make a bond. And if it wants to make a bond, carbon now can have 5 bonds. So it is not possible. So what will happen? One of the pi bond will break, and the oxygen will get a lone pair. So see, these are H or R, whatever it is, and this will be R here. Now O will be having a negative charge. Since magnesium has lost a bond, so Mg will gain a positive charge here, and a bond with X and a bond with X. Okay. Now this thing here, it is called adduct. Okay, it is called adduct. Should I write it? It's called adduct. Okay, now further treatment with H2O. When I treat this with H2O further, what happens? In H2O, we get this O gets the H and Mg get the OH negative, right? So we have two things in H2O now. We have H and OH. H2O can dissociate in this fashion, H and OH. So H goes to, this is delta, this will be positive, obviously. H is a proton. It will go to O negative. So we'll be having C, R, OH plus. Now OH is negative. Now this OH is negative. So Mg will gain the OH. Will be now Mg OHX, Mg OHX. Okay. So note down this, and we will deal with some different kinds of aldehydes and ketones, and we will do some questions. Done. Okay, great. Now let us have different kinds of aldehydes and ketones. First of all, if we have aldehyde and if we have methanol, So first of all, RMgX plus CHO and HCHO. This is methanol. Methanol. Okay. Now, now just remember this R can be anything. Okay. This R can be any alkyl group, any alkyl group. So for here, what I'm doing, I will first of all give the reaction and then give a example of R also. Okay. I will put some alkyl group in this R and then give you the reaction. So simple as that. We have H, which will be bonded to CO like this. I need to give CO some kind of respect like this, CO and H. So this is methanol. This is methanol. Plus we have RMgX, RMgX. So now you know the product what will happen, correct? You know the product what will happen. This R will get attached to like this, H, H, and R, and this will be being converted into OH. Plus you will get MgOH. X. Okay. Now just remember here. Now if I want to do examples, for example, now if R is equal to one of our, let us take R is equal to CH3. R is equal to CH3. Then what will be the product? HCHO plus CH3 MgX, and you will be getting what? You will be getting here H2COH CH3. Okay, I'm writing this in the proper form, so I can write this as equivalent to CH3 CH2OH. So you should remember that this is a 1 degree alcohol. This is a 1 degree alcohol. Now let us take any, okay, let us take R is equal to, for example, CH3 CH CH2. Okay, R is equal to this, and this CH is bonded to Mg. This CH is bonded to Mg like this, MgX. Okay, so it is isopropyl kind of group. It is isopropyl kind of group. Okay, isopropyl. R is equal to CH3 CH and like this. So we have HCHO again, plus we have CH3. It's bonded to CH. It is bonded to Mg, and it is bonded to CH3 again. Now what will be the product? So the product will be here. Now you tell me there are three carbons, right? You have these two carbons are same, if I am right. I'm denoting this red carbons are same. Can you see that? Yes. And this green one is different. This green one is different because it has only one hydrogen and it is bonded to Mg. These have only CH3, which is bonded to CH. Correct? CH is different than these CH3. Yes. Okay. Now you tell me, will the red one attack the CO or will the green one attack the CO? Which will attack the CO? Red or green? Okay. If you are in doubt, then just put the red you guess. Okay. Now let us go back a while. Let us go back a while. Okay. Now, oh, sorry. I should change the color first. MgX. Now let us do one thing. Let us put the charges. It is electron flow, nothing else. Let us put the charges. Let me make HCHO in a better way. So I can write H, carbon like this, and H. This is delta positive. Okay. Now you tell me what this CH will be delta positive or negative? Okay. You said something different here. See this. This CH is bonded to what group? CH is bonded to what? No. CH is bonded to what? No. CH is bonded to what? Mg. Mg is a metal or non-metal? Magnesium is a metal or non-metal? Metal. So what is the property of metal? To lose electron or to gain electron? Lose or gain? Metal has the tendency to lose electron or gain electrons. Lose electrons. So if it will be losing electrons, that means Mg will be positive or negative. Mg will be losing electrons now. So Mg will be giving electrons to CH. So CH will be negative, right? You said it right in the first time. In the first time you said it right, okay? So now here this delta negative, it will attack to the carbonyl carbon like this. And you will get a product H, C, H. Now this carbon CH will be here and it will be bonded to CH3 and CH3 like this. Now this O double bonded O will be getting converted to OH. And similarly here MgX, what was here, it will be getting converted into MgOH. X. No, the other two carbons are not positive. These are also delta negative, but these have less negative charge than this particular carbon. Correct? Because inductive effect na distance dependent. Inductive effect is distance dependent. So the one which is near to the electropositive element, that is magnesium, that is metal, will be gaining the more delta negative charge. Okay. So can you see the product? Can you see the product? Okay. So you don't have to do anything. Okay, you don't have to do anything. Whatever is bonded to X, you just take it out and bond it to the carbonyl carbon. Okay, note this down. Then we will move on to this is one type of aldehyde. We can have different type of aldehyde. Here, what is the case? Here also you can see that this is 1 degree alcohol. This carbon, this alpha carbon is bonded to only one carbon. It is only bonded to one carbon. This is also 1 degree. 1 degree alcohol. So one thing that you can say is if methanol reacts with any Grignard reagent, we will get 1 degree alcohol. We will get 1 degree alcohol. Okay, you will get 1 degree alcohol. So it's primary alcohol. Now this sign here is the sign is of equivalent to. Okay, I mean these two structures are same. These two structures are equivalent. I mean, better you write it somewhere that this sign here, it means equivalent. Okay, this triple equality sign. This means equivalent. Equivalent. And here what is happening? This CH3 is attacking to this carbonyl carbon. This having sense, delta negative, this is delta positive. Done. Okay. Now, if we have some, we have, for example, RMGX plus RCHO. RCHO, that is aldehyde other than methanol. So what will be the product here? So it is the same thing, same scenario, which was in the earlier case. We dealt it in detail here. So what I will make here carbonyl carbon like this. This is the carbonyl carbon. It is attached to an R group and it is also attached to a H group. Okay, it is attached to R group and a H group. Now I want to react this with RMGX. That is alkyl. Sorry, this is Grignard reagent. Now what will happen? This delta negative, this is delta positive, obviously, and this will go and attack to this carbonyl carbon, this carbonyl carbon. Okay. So what will happen? Same thing. R is bonded to carbon. It is C double bond O. This has H already. Now what will happen? This CO double bond O will become OH, and I will be getting R here. I will be getting R here. Now you can see that this alpha carbon is bonded to how many alkyl groups? This alpha carbon is bonded to how many alkyl groups? Two. So this will be what carbon? 2-degree alcohol or secondary alcohol? Okay. Now you can have an example like this. If I take, let us take this as R dash. Okay, R dash. So let us take R dash is equal to CH3. And wait a second. Sorry for that. This is R dash. So this will not be R dash. CH1. Let us take RMgx as dash. Okay, R is equal to R dash is equal to CH3, and let us take R is equal to also CH3. Simplest example. Simplest example. CH3 CH3. So what are we reacting here? First of all, we have carbonyl carbon in which we have C double bond O. Now this C double bond O, it is attached to carb CH3. This is the R and H, and we are reacting this with CH3, which is bonded to Mg. X. This is Mgx. So what will happen? Nothing different. Delta negative. This delta negative will attack on CO. So you will be getting H3C. This is already attached. These all are already attached. You will get one new bond, which is CH3, and one pi bond will be broken, and you will be forming alcohol. Now you can see that this carbon, again, this alpha carbon here, it is attached to CH3, CH3 to CH3. So this is 2-degree alcohol. 2-degree alcohol. Okay. 2-degree alcohol. So if you have aldehyde, which is other than methanol, you will be getting 2-degree alcohol. You can take any example. CHO plus. Let us take again CH3MgX, or you can take any kind of MgX. Okay, let us take like this. MgX. You will be getting a product like this. CH2OH. CH2OH, and this carbon will be attached to this carbon like this. Got this? 2-degree alcohol. You get this idea, right? This carbon is attached to Mg. Now the same carbon will be attached to the carbonyl carbon. Okay. And you can note this down. Then we will move to ketones. Note this down. We will move to ketones. Okay, great. Now let us move on to the third case, that is for ketone. Third case, again we will have RMGX, same thing, plus I will have RCOR. Okay, you understand this? RCOR, this is ketone. Now I have to do this as R, this will be as one, this will be double dash. Okay, so I mean I mean that this R and these all R's are can be different and can be same also, can be different and can be same also. So okay, now how was I writing previously? Okay, this is ketone. Ketones. RMG is Grignard reagent plus ketones. So if I have RMGX, wait a second, I should write first of all the ketone R is bonded to carbon and it has two R groups, one dash, this is double dash, plus I have R is bonded to MgX. So this will be delta negative. Same story. Attack to the carbonyl carbon and I will be getting R dash which is bonded to carbon. Now this has also R double dash. Now I will get another R from RMGX and this double bond O will be converted to OH. Now you tell me this alpha carbon is connected to how many alkyl groups? 3. So this will be 3-degree alcohol. 3-degree alcohol, or we call it also as tertiary alcohols. Tertiary alcohol. Okay. So for example, you can take anything. Let us take as double bond O and here, plus let us take CS3, MgX, and the product that I will be getting is OH, and here I will be getting CS3. Okay. Now if I have something like this, let us take a cyclic compound for a change. Double bond O, plus I have something like this. Let us take MgX. Now you should remember that this is 1 carbon, 2 carbon, 3 carbons, and I will be getting like this, something like this. OH, and there will be 1 carbon, 2 carbon, and 3 carbons. Okay. If you want to have some more example, let us take a simple ketone plus a different type of, let us take one more carbon here. So the result would be, the product would be alcohol. Now this alcohol, let me take it like this. So you have 1, 2, 3. The same thing here, like this. Okay. So all of them are 3-degree alcohols. 3-degree alcohol. Note this down. Let me know when you're done. Done. Okay. Now keep answering. Okay. Preparation of alcohol. Preparation of alcohol. Okay. Now the first thing is from alkene. From alkenes. From alkenes. Number one, the first case would be the presence of, this is H2O, H plus. Now second is from diborane with the reaction of diborane. Okay, diborane. Now you tell me here, Markovnikov product or anti-Markovnikov product? The first one, MP or anti-Markovnikov products. You will apply the Markovnikov's rules or anti-Markovnikov's rules in the presence of hydrolysis. Okay, then just do this one and MP or okay, fine. This is MP Markovnikov's. What about diborane and second diborane anti? Correct. Now, secondly, we are from carbonyl. From carbonyl, if you want to from carbonyl by reduction, from carbonyl by reduction. Okay, by reduction. So you will have either aldehyde, you will have either ketone, you will have either acid, you will have either ester, you will have either acid chloride. So aldehydes and ketones, they will be both of them H2PD, NABH4, LiAlH4. LiAlH4. What about acids and esters? From acids, I have only LiAlH4. What about ester? For ester, I have LiAlH4 plus, and I can also reduce this by H2PD. Also reduce this by H2PD. What about acid chloride? Acid chloride by sodium borohydride NaBH4, LiAlH4, and also from LiAlH4, sodium borohydride, and okay, yeah, these two only. Now, the third part that we learned was from the Grignard reagent. From Grignard. So from Grignard, you can have either, number one, you can either have methanol. If you have methanol, you will get 1 degree alcohol. Secondly, if you have any other aldehyde, you will be getting 2 degree alcohol. If you have C, any other ketone, any ketone, you will be getting 3 degree alcohol. Okay, you have to revise these things only. You have to remember these things only. From alkene, there are two ways by which we can make alcohol. Either by hydrolysis in the presence of acid, you will get a Markovnikov product, or by diborane and then H2O2 in the presence of NaOH. Also, you remember this diborane, and after that H2O2, that is hydrogen peroxide in the presence of sodium hydroxide. You will be getting anti-Markovnikov product. From carbonyl carbon, you can have either of these carbonyl carbons, and you will use the reducing agent. I mean, you will use the reducing agent appropriately. Okay, whatever reducing agent you want to use. Now, this lithium aluminum hydride LiAlH4 is common in all of them. You can use LiAlH4, but if you have to do selective reduction, for example, if you have a compound in which there is aldehyde and acid, both of them, but you want to only convert and you want to only reduce the aldehyde, then you will use what? You will use NaBH4. You will use NaBH4. Okay. So remember these things. Now, moving on to preparation of phenols. Preparation of phenols. So phenols can be prepared by, so the first one is, I guess you remember this, the phenol can be prepared from haloarenes. Number one is from haloarenes. So what is the reaction from haloarenes, and specifically from chlorobenzene? So when chlorobenzene is treated with NaOH in presence of high temperature, and pressure, we obtain phenoxide ion. We obtain phenoxide ion, and more specifically speaking, sodium phenoxide. Sodium phenoxide. On further treatment with acid, we get phenol. So I hope you remember this reaction. This is chlorobenzene. Now this is chlorobenzene. Now this has reacted with sodium hydroxide, high temperature and pressure. So the way to remember the temperature here is, and pressure is, see, in this you have how many carbons? You have 6 carbons. And when you divide this by 2, you will get the number of bonds. 6 carbon atoms divided by 2, you will get 3 as the number of pi bonds, okay? And 300 atm. And you will get sodium phenoxide. What is sodium phenoxide? This is phenoxide ion with O negative and an Na plus here, sodium phenoxide. A further treatment with acid, H plus, you will be getting OH. This is phenol. Okay. Copy this. Okay. Yeah. Now next is from benzene sulfonic acid. There's from benzene sulfonic acid, or you can have from benzene also. Okay. From, not directly from benzene. That is why I'm writing from benzene sulfonic acid. Benzene sulfonic acid. So what is the reaction here? What is the reaction? See, you must have seen this reaction that benzene is getting converted to, benzene can be converted to, this is benzene, and this can be converted to benzene sulfonic acid by sulfonation. SO3H. So you can have various sulfonating agent. I hope you remember that H2SO4, concentrated H2SO4 can be used, but also oleum. There is one product which is called oleum. Now, this is available cheap. This is available, and it is, the formula for this is H2S2O7. This H2S2O7. This H2S2O7. Now, how does this look? It has, first of all, let us make OH. This is bonded to sulfur, which is bonded to oxygen, and another oxygen like this. So how many oxygen do we have now? We have two more left. So it looks like this. Okay, this is oleum. It has the same. Now, what happens here? There are these two protons can be used, right? These two protons can be used. It is diprotic. So this is oleum. Now, when it is reacted with benzene, we get benzene sulfonic acid. Now, same thing. That is, first of all, you give it NaOH, sodium hydroxide. Secondly, you give it acid H plus, and you will be forming phenol. Okay. So oleum, it is nothing but sulfonation reaction. Nothing but sulfonation reaction. So you can write something like this: that benzene on sulfonation. Benzene on sulfonation gives benzene sulfonic acid. Further treatment with NaOH, then H plus gives phenol. You can note this down. Remember the structure of oleum. This is new. I have written sulfonation and not specifically oleum because sulfonation can be also done in the presence of H2SO4, that is concentrated H2SO4. Okay. Okay, done. Moving on from Dizonium salts. Third case is from Dizonium salt. I hope you remember Dizonium salt. From Diazonium salt. Now, Dizonium salt is prepared by, if you remember it, Dizonium salt is prepared by the reaction of aniline. What is aniline? Benzene bonded to NH2. And you react this with NaNO2 and HCl, you get benzene disonium salt, that is BDS, benzene disonium salt, N2 plus Cl negative. Now you just have to, what you have to do, and also remember this is from 0 to 5 degrees Celsius, okay, 0 to 5 degrees Celsius. Now what you do, you add H2O and just warm it, nothing else, you just warm it. So what you will be forming? You will be forming phenol. One thing you have to remember here, that is why benzene disonium, you will not see benzene disonium salt in laboratory. Benzene disonium salt, let me write it BDS. BDS is always reduced in C2. What does in C2 means? In C2 means that we have aniline and we add NaNO2 and HCl, and then we prepare. This is in the reaction itself, in the reaction beaker itself. Okay, we cannot separate it out in C2 because it easily reacts with moisture to form phenol. Okay, you have to remember this point. That is why we always write aniline. Then we produce this BDS. This is benzene, Dizonium salt. This is phenol. This is aniline. Okay. Note this down. Then we will move to the fourth and the last one. That is from cumene. The reaction of this is not in your syllabus. Now, if you will come see the aniline reaction, it is the reaction of aniline mainly, na? Right? See, for H2O, I can easily you can also see this N2 plus Cl negative, and this N2 plus and Cl negative is there, and we have H and OH. So what will happen? This HCl can abstract this H, and this is N2 plus. This nitrogen is already very electronegative. Now with positive charge, it becomes more electronegative, more electron pulling. So this carbon will become delta negative. Sorry, this carbon will become delta positive. It will pull all the electrons. It will pull all the electrons. Now this OH, it has lone pair. So what will OH do? OH will go and attack this carbon. So you will be getting phenol. Now, aniline to benzene diazonium salt, I will discuss in the chapter amines. Okay, in amines, we will discuss this reaction, preparation of benzene diazonium salt. Okay. Now here you can see easily, na? I hope you can see this reaction easily. Delta positive and delta negative, if you just do the signs. Let me know if you're done. Okay, you're done. Now let us move on to the fourth preparation of phenol, that is the last from cumene. Cumene is a commercial name. The chemical name of this cumene is isopropyl benzene. It is isopropyl benzene. Isopropyl benzene. So how does isopropyl benzene looks? You have a benzene ring. You will attach a carbon here, and this carbon will be attached with two different carbons, right? CH3, CH3, CH3. Now this carbon will be having one more H, correct? So this is cumene. Now, if you react this cumene in the presence of O2, then what happens? This O2, it gets inside the C and H bond. So you have the CH bond now, the CH bond here. Let me put this here like this. H. So this O2 gets inserted into CH3. This is also CH3. OOH. This is OOH. Now what will be this called? This will be called as cumene hydroperoxide. Cumene hydroperoxide. Then the reaction with acidified water, what do you get? You get phenol, plus a ketone. So what you can see here, what is happening is that this particular whole thing, this whole thing is getting removed. This whole thing is getting removed, correct? This whole thing. Oh, sorry, I missed this oxygen. This oxygen is also getting removed. So oxygen is also getting removed with the electrons, and this OH negative, this OH is just shifting its place and coming to this carbon, right? It is coming to this carbon. So what is happening? You are getting phenol from this carbon, and you are getting a ketone from this CH3, this isopropyl group. So this is a phenol here, and you also get a ketone. You also get a ketone, and that is why, see, you are getting a ketone, which is also an organic product. You're getting a phenol, which is also an organic product. And relatively speaking, from all the previously used reagents, for example, we used a reagent. So this is a very costly method. This is very costly, right? Why it is very costly? Because we need to give so much of energy and so much of pressure. So all of this needs some money. So this is also very costly. What about this one? We are using a very strong acid, and then we are using a strong base here. We are using a strong base here. So this is, it has what I can say, not very safe. Not very safe. Okay. Now, what is the problem for this one? In this one, we need it is condition dependent. It is condition dependent. For example, this 0 to 5 degree, you have to keep the environment 0 to 5 degree. You have to have some water bath in which there is some ice, and you have to prepare the sodium benzene diazonium salt in 0 to 5 degrees Celsius. So it is condition dependent. Now let us see this. What is good about this is, what is from cumene? This is easily available. Now what does H plus and H2O means? It means slightly, dilute acid. Okay, and hence this method from cumene, it is the industrial method. It is the industrial, or I can also say commercial method. Commercial method to prepare phenol. To prepare, oh my God, what did I write? Pheon, not pheon, phenol. Prepare phenol. You can write this down. If I want to write this specifically, this is acetone. Acetone. Now, if you want to know, in Gujarat also we have, phenol is produced in, what can I say? I guess some million or billion tons every year. And in India also, we have a plant in Gujarat also, a newly formed plant in Gujarat that forms phenol and acetone. Then we have in Bengal also, there is one plant which produces phenol and acetone in high amount, and they all produce from cumene only. The same procedure is applied. So it is it is the industrial and commercial method. That means it is very cheap. It means that it is very cheap method to prepare phenol. Remember this from cumene. Done. Okay, fine. Now let us do a quick thing regarding physical properties. Okay, physical properties. Okay, before I forget, just write this. You have to try the questions in, okay, in NCERT. You have to try these questions, NCERT, in text. Okay, that means in between text you will be having question number 11.4. If you have book, somewhere near, just tell me. Can you see the question number 4 here? Sorry, in the NCERT 11.4. Then I will move to physical properties. Yes. So the question reads, and just tell me yes or no. Show how are the following alcohols prepared by the reaction of a suitable Grignard reagent on methanol. Suitable Grignard reagent on methanol. Correct? Okay, fine. I guess you have written yes, sir. Okay. Now let us move on to physical properties. Physical properties. So first of all, we will deal with what? The melting points and boiling points. Okay, the melting points and boiling point. Okay, so both of them, the melting and boiling points, and I won't say melting point, and I will only discuss about boiling points because majority of the alcohol, they are present in liquid form. So boiling points. So boiling point, we know that boiling point of any alcohol or anything, boiling point is directly proportional to, first of all, we will see the molecular mass. Okay, then it depends on hydrogen bonding. Correct? I mean, when I say molecular mass, I mean that it depends on the van der Waals interaction. I hope you remember that. Boiling point. Boiling point, that means we have to check boiling point. Boiling point is directly proportional to intermolecular forces of attraction. Okay, forces of attraction. So now if I want to have IMF, intermolecular forces of attraction order. So the least you have for van der Waals forces. Van der Waals, I guess van der Waals forces. Now, van der Waals forces is directly proportional to molecular mass. Okay, now this is the least. Then after that, this is greater than sign. You will have dipole interaction. Now greater than dipole interaction, you have hydrogen bonding. You have hydrogen bonding. Okay. So let us do this with an example. Let us first do this with an example, then we will do some more. If you have, for example, question is pentane 1-ol, pentane 1-ol. Then you have normal butane. Then you have pentanal. Then you have ethoxy ethane. Okay, just quickly doing this. Pentane 1-ol, that means 1, 2, 3, 4, 5, and OH 1, 2, 3, 4, 5 OH. And butane is 1, 2, 3, 4, normal butane. And then there is pentanal, so 1, 2, 3, 4, 5, and CHO. Now you have ethoxy ethane. So ethoxy, CH3CH2O, ethoxy, then ethane, CH2CH3. This is ethoxy, this is ethane. So in this, if I want to compare here, so first of all, I can see that this has number of carbons, 1, 2, 3, 4, 5. This has number of carbons. This has 5 carbon, this has 4 carbon. Now this has how many? 1, 2, 3, 4 carbon. This is having 5 carbon, and this has 1, 2, 3, 4 carbons. Okay. Now if I want to do a molecular mass, So if I want to attach molecular masses, then I can see that this has 5 carbon, this has 5 carbon, then these two will be comparable. 1, 2, 3, and 4. Between 1, 2, 3, 4, 1 and 3 will be comparable because these have similar molecular masses. I mean, 4 cannot be in any, can be near 5 or 4, 5 or, sorry, second or third one, second or fourth one, okay? So in this here we have OH, and then in this we have CHO. So how does CHO looks like? Let us see that first. This is double bond O and this is H. This has obviously hydrogen bonding because O and H is there. And here the bonded H is bonded to carbon. Here H is bonded to oxygen. Hence this has the highest melting point. This has the highest melting point. This pentane 1-ol. Then if I want to move on, to next one, then I can say that this fifth one will be having the next one. So I can say pentane 1 is highest. Then second one is the third one, pentanal. Then we have between second and fourth, we will compare the molecular masses. So in this we have only 4 carbons. Here we have 4 carbon plus an oxygen also. So the next one will be fourth because it has oxygen also. And then the next one will be second. So first of all, you have to look at the number of carbons. And if you have something comparable, then you will look at, if you will look at the hydrogen bondings there, you will look at hydrogen bonding there, okay? So more on physical properties in the next class. For now, don't write anything. We will discuss in more detail with more examples. Okay, you can just write this. Now, hydrogen bonding, it is when, okay, 1 is greater than 3. Wait a second. When H is bonded to fluorine or oxygen or nitrogen. Okay. So if you want to compare 1 or 3 now, so let us take this OH. So here the molecular masses will be the same, correct? This also has 5 carbon, this also has 5 carbon. Molecular masses will be not same, but it will be comparable. Yes. Now tell me, this has H directly bonded to oxygen, correct? This will be delta negative, this will be delta positive. So what happens is you will get another one which has H here and O here, and you will get 1, 2, 3, 4, and 5. Okay, 1, 2, 3, 4, 5. And here what will be having delta negative and delta positive. So can you see an interaction happening here? Can you see an interaction happening here? So this type of interaction which happens, now what happens here? The IMF increases, na? Intermolecular forces of attraction increases. No such interaction is here, correct? No such interaction is here because H is bonded to what? H is bonded to carbon and not oxygen. Got it? H is bonded to carbon. No, just remember this: when H is bonded to oxygen, H is bonded to nitrogen, or H is bonded to fluorine. Now, all of them are nothing but delta positive. Here, delta positive, delta positive, delta negative, delta negative, delta negative. Okay, let's do one thing. In the next class, I will deal with hydrogen bonding first of all. What is hydrogen bonding? Then we will discuss the later parts. Okay, we will deal with hydrogen bonding in all of these types of molecules. Okay. Okay. So, can I end the class now? Have you written everything down? Oh, the previous slide? Yes. Now, dipole interaction directly depends on dipole moment. Of the molecule. Okay, of the molecule, and not a bond, not a particular bond, but of the molecule, the whole molecule. You show it like this.